Hello students, welcome back to Future Foundation. Students, in today's class of straight lines, we will discuss position of a point with respect to the line and equation of angle bisectors. So let's start the class. So write down the heading, position of a point with respect to a line. Position of a point with respect to the line. Okay. So in this, three cases are possible, or three positions are possible. Let us discuss one by one. Position 1 is, let's say this is line ax plus by plus c is equal to 0, and point is somewhere above the line. So if I place x and y x coordinate and y coordinate of the point, and if it becomes positive, then we can say point is above the line. Okay. Position 2, if again this line is ax plus by plus c is equal to 0 and point is lying on the line. So in this case, ax1 plus by1 plus c becomes 0. It implies what? Point is on the line. Okay. And third position is, if this point is lying below the line, then ax1 plus by1 plus c is less than 0. Means point is below the line. Okay. Now we have discussed position of a point or position of single point with respect to a line. Now we will also discuss position of 2 points with respect to the same line. Position of 2 points with respect to the line. So let's say this is case 1, or this is line ax plus by plus c is equal to 0. Here is point P and here is point Q. Coordinates of point P h comma Q, coordinates of Q is P comma Q. And we are saying that P and Q are lying on the same side of the line. So in this case, this is L. L of h comma k into L of P comma Q is greater than 0. Implies both points are on the same side of the line. Okay. Let's say this is another case. Point P is h comma k and point Q is P comma Q. And in this case, P and Q are on the opposite side of the line. Right? Means ax plus by plus c is equal to 0, which is L. So in this case, L of h comma k into L of P comma Q is less than 0. If product is negative, implies both points are on the opposite side. Both points are on the opposite side of the line. Means L of h comma k is nothing but value of this becomes, on replacing x and y by coordinates of the point. For example, let us say take a question. If 1 comma 2 and 5 comma 7 are found opposite to the line 2x plus y minus lambda is equal to 0. Then find integral values of lambda. Okay, so L is 2x plus y minus lambda is equal to 0. Now, as according to question, L of 1 comma 2 into L of 5 comma 7 must be negative because points are on the opposite side of the line. It means 2 into 1 plus 2 minus lambda into 2 into 5 plus 7 minus lambda should be negative. Means 4 minus lambda into 17 minus lambda should be negative, or lambda minus 4 into lambda minus 17 should be negative. Implies lambda is lying between 4 and 17 open. It means integral values of lambda will be lambda is equal to 5, 6, 7 and so on up to 16. These are the possible integral values of lambda. Now let us take one more question based on the concept discussed. If a comma a square is lying between y is equal to x square by 2 and y is equal to 3x, then a belongs to question mark. Which way? This point is lying between y is equal to x square by 2 means it is a parabola, upward parabola, and y is equal to 3x is a line, and this is, or this point P is this a comma a square. So I am now I am extending the concept from line to curve. As this point is lying between this region, so this point is above the parabola but below the line. So if I'm saying line is 3x minus y is equal to 0 and parabola is x square minus 2y is equal to 0. So according to question, L of a comma a square into p of a comma a square should be negative because with respect to line it is below. So for line, L of a comma a square is less than 0, but it is above the parabola. So p of a comma a square is greater than 0. So product of these two will be negative. So this is 3 minus a square into a square minus 2a square negative, or a square minus 3a 2a square is negative, or a common, so a cube a minus 3 is negative, or a into a minus 3 is negative. So a is lying between 0 and 3. So this is the required interval for a. Okay, now let us come to next topic, which is equation of angle bisectors. So write down the heading, equation of angle bisectors. So what are angle bisectors? First of all, write its definition. Angle bisector is the locus of a point in a plane which moves so that it remains equidistant from the given lines. Okay, what I'm saying, let us understand by figure. Let's say these are two given lines and I have to find the angle bisectors for these two. Say this is L1, this is L2. What I'm saying, angle bisector is the locus of a point which moves in a plane so that it remains equidistant from these 2 points, from these two given lines, that is this length and this length will always be equal and distance is always perpendicular. So PM and PN are equal. Why PM and PN are equal? I can prove this by using congruency. As this is angle bisector, so this is theta and this is also theta. I'm taking triangle PON and POM. So angle PON is equal to angle POM, and so I have to prove why these two angles are equal. Okay, so according to the definition, this PM and PM are equal. Okay, PM is equal to PN by definition. Okay, and OP is equal to OP common, right? And angle P and PMO is equal to angle PNO, each 90. So by using RHS congruency, triangle PON is congruent to triangle POM, right? So angle PON is equal to angle POM. That's why it is angle bisector. Okay. Okay. Now I have to make an equation for this bisector. So that is, say this point P is having coordinates h comma k. So by using perpendicular distance formula, this will become mod of E1h. Say L1 is E1x plus B1y plus C1 is equal to 0. E1x plus B1y plus C1 is equal to 0. And this L2 is A2x plus B2y plus B2y plus C2 is equal to 0. Okay, so from this E1h plus B1k plus C1 on root over A1 square plus B1 square is equal to mod of A2h plus B2k plus C2 on root over A2 square plus B2 square. Okay, and after removing modulus and replacing h and k by x and y, locus will become like this: a1x plus b1y plus c1 on root over a1 square plus b1 square is equal to plus minus e2x plus b2y plus c2 on root over e2 square plus b2 square. So here we can see that there are two equations, one for positive and one for negative. It means there are two angle bisectors. Okay, so this is bisector b1, then this is bisector b2. So there are some points on node 1. There are two angle bisectors. One is acute angle bisector and other one is obtuse angle bisector, right? Point number 2, these two angle bisectors are always perpendicular. These two angle bisectors are always perpendicular. We can verify this point by using concept of slope, okay? Because as you in front of you there are two equations, and using equations you can find slope, and taking product you will find product will be -1. Okay. Point 2 is these two angle bisectors are always perpendicular. Point 3, how to determine obtuse and acute angle bisector. So there is rule for determining obtuse and acute angle bisector, that is which one is acute angle bisector and which one is obtuse angle bisector. So for this we have to make C1 C2 for the same sign. So make C1 C2 positive. Let's say we are making C1 C2 positive. Then if A1 A2 plus B1 B2 is greater than 0, then bisector with positive sign will give or will be obtuse angle bisector. Obtuse angle bisector. So bisector with positive sign will be obtuse angle bisector, and then bisector with negative sign will be acute angle bisector. And if A1 A2 plus B1 B2 is less than 0, implies bisector with negative sign will be obtuse angle bisector. So it is very simple. It is very easy to remember. Sign having A1 A2 plus B1 B2. A1 A2 plus B1 B2 is of that sign will give the obtuse angle bisector. Okay, so it is very easy to remember. Now note 3, note 4. For this there A, B, C. Note 4th, how to find which bisector contains the given point. which bisector contains the given point. Let Px1y1 be the given point. L1 of x1y1 into L2 of x1y1 is positive, implies x1y1 lies in obtuse angle bisector. If L1 of x1y1 into L2 of x1y1 is negative, then x1y1 lies in acute angle bisector. Right? So, and if L1 x1 y1 to L2 x1 y1 will be less than 0, implies x1 y1 lies in acute angle bisector. Acute angle bisector. Okay. And no need to find the case for origin, because origin is also a point. Okay. This point is sufficient for origin also. Now let us write a question. Question is, find equations of bisectors, also find acute angle bisector having origin and bisector having 1, 2 for the lines 4x plus 3y minus 6 is equal to 0 and 5x plus 12y plus 9 is equal to 0. Okay, so L1 is 4x plus 3y minus 6 is equal to 0, or I am writing by taking minus sign common, as I am making constant term positive. So you can say L1 is this and L2 is 5x plus 12y plus 9 is equal to 0. So equation of bisectors 4x plus 3y minus 4x minus 3y plus 6 upon root over 4 square plus 3 square is equal to plus minus 5x plus 12y plus 9 upon root over 5 square plus 12 square. So one is positive, one is for positive, one is for negative. So bisector P1 is minus 4x minus 3y plus 6 into 13 is equal to 5x plus 12y plus 9 into 5. Okay, so B1 is 4x plus 3y minus 6 over, after multiplying 13 minus 52x minus 39y plus 78 is equal to 5x plus 12y 25x plus 60y plus 45, or B1 is 77x plus 99y minus 33 is equal to 0, or b1 is 7x plus 9y minus 3 is equal to 0. This is bisector 1. And b2 is minus 4x minus 3y plus 6 to 13 is equal to minus 5 times 5x plus 12y plus 9, or minus 52x minus 39y plus 78 is equal to minus 25x minus 60y minus 45. So this will be 27x minus the 21y, 21y minus the 123 is equal to 0, or 9x minus 7y minus 41 is equal to 0. This is B2. As we can see, P1 and V2 are perpendicular because slope is minus 7 by 9 in this case, and for V2 slope is 9 by 7. Okay, now these two are equation of bisectors. Now what is acute angle bisector? So for this we have to find A1 A2 plus B1 B2. So A1 A2 plus B1 B2 is minus 5 into 4 into minus 4 into 5 and minus 3 into 12, which is less than 0. So in this case B2 is acute angle bisector, B2 is obtuse angle bisector, because with the B2 there is minus sign. So B2 is obtuse angle bisector, and B1, which is 7x plus 9y minus 3, 7x plus 9y minus 3 is equal to 0, is acute angle bisector. Now point number 3 is which bisector is having origin. So L1 of 0 0 into L2 of 0 0 means I have to put in line 1 and 2 0 0 in place of x and y. So this will become 0 0 plus 6 into 0 0 plus 9, 0 plus 0 plus 6 into plus 0 plus 9, which is positive, implies bisector with positive sign will contain origin, or acute angle bisector is having origin, or is containing origin. It doesn't mean that it lies on the angle bisector, but it means that in that region in which this bisector is lying, in that region origin is lying, is containing. Point number 3 is which bisector is having origin. So L1 of 0 0 into L2 of 0 0 means I have to put in line 1 and 2 0 0 in place of x and y. So this will become 0 0 plus 6 into 0 0 plus 9. 0 plus 0 plus 6 into plus 0 plus 9, which is positive, implies bisector with positive sign will contain origin, or acute angle bisector is having origin, or is containing origin. It doesn't mean that it lies on the angle bisector, but it means that in that region in which this bisector is lying, in that region origin is lying, is containing origin, right? And fourth one is L1 of 1 comma 2 into L2 of 1 comma 2 means L1 is minus 4 into 1 minus 3 into 2 plus 6 into 5 into 1 plus 12 into 2 plus 9 minus 4 minus 6, so which is negative. It means obtuse angle bisector, that is B2, or 9x minus 7y. 9x minus 7y minus 41 is equal to 0 is containing 1 comma 2, right? So students, in this class we are done. Let's meet in next class. Till then, bye bye and take care.